Hello everyone. Today we are going to discuss the behavior of real gas. Yesterday I have uploaded a video of kinetic gas theory numericals and Maxwell-Boltzmann theory numerical. Today I am going to upload this video of behavior of real gas and the deviation from ideal gas behavior. Means if a gas deviates from its ideal behavior, it is going to become the real gas. So before discussing behavior of real gas, what is ideal gas? Ideal gas is a gas which obeys the general gas equation. What is general gas equation? Is PV is equal to nRT and other gas laws at all temperature and pressure. In real, there is not at all any ideal gas. Means ideal gas exists. Ideal gas is that gas where there is no force of attraction between the molecules, between the gaseous molecules. So how we can say that there is a no force of attraction? If there is large distance between them, how we can have this large distance between the molecules? By having high temperature. Means if the temperature is going to become high, kinetic energy is also going to become high. And at low pressure, means if we are not going to compress these molecules, they are not going to come near each other. So ideal behavior is that behavior gaseous particles are at very large distance from each other. This is I am showing you only on the basis of this paper, but the gas molecules are even far away than these points. So we thought that according to Boyle's law, PV versus P graph for ideal gas is constant. Okay, we can say a straight line. But in actual practice, this is for ideal gas. In actual practice, there is not at all any ideal gas. So we got a behavior like this. Something for H2 and Hg. Okay. For CO and CH4. We want that from our previous Boyle's law experiment that we have this line, we have this constant line. But after performing the experiment, we got this H2 line that is going to be above than this one, and He line also above than this one. Means this is the positive deviation from this line, and this one is the for CO and CH4, first the negative deviation and then the positive deviation. And what we were expecting, that the line should be a straight line if all the gases are ideal gas. But now we are saying that these are real gases. In reality, we have performed some experiment and we are getting this graph after performing PV versus P. After plotting PV versus P graph. Okay. And when we plot P versus V graph in the Boyle's law, it is like the hyperbola. If you don't know how it is going to form, because I have discussed it during the Boyle's law, and I'll give you the description in the link. I will give you the link in the description box. So this is the high pressure. This curve is for ideal gas and this curve is for real gas. Okay. This is low pressure. This is real gas. This is ideal gas. Okay. At high pressure, volume of real gas is greater than volume of ideal gas. At high pressure, volume of real gas is greater than ideal gas. At low pressure, volume of ideal gas is almost similar to that of real gas. I have already told you the conditions of ideal gas behavior, that is high temperature and low pressure. So what is this? This is low pressure. So almost real gas approaches the ideal behavior. Okay, did you understand that? Okay, now to study the deviation of real gas from ideal behavior, we need to plot the graph of PV divided by nRT versus P. PV divided by nRT is compressibility factor Z. Compressibility factor. For ideal gas, Z is less than 1. For ideal gas, Z is equal to 1. So PV divided by nRT is equal to 1. PV is equal to nRT. For real gas, Z is less than 1 or Z is greater than 1. If one formula that I want to discuss is Z is also equal to V real divided by V ideal. So here I have V real divided by V ideal less than 1. Here I have V real divided by V ideal greater than 1. V real is less than V ideal if Z is less than 1. V real is greater than V ideal if Z is greater than 1. So what does this mean? If volume of ideal gas is greater than volume of real gas, means gas is more compressible. Means we can compress this gas more. That's why it is going to be less, because volume of the real gas is less, and V real is greater than V ideal means gas is less compressible. We cannot compress that gas to a small volume. It is going to reach far compressible. Okay. Z is less than 1 is meaning negative deviation. When Z is less than 1, negative deviation. And here if Z is greater than 1, positive deviation. Okay. Now, positive deviation from ideal behavior and negative deviation from ideal behavior. Okay, now I am going to plot this PV divided by nRT. PV divided by nRT is Z versus P. Okay, if the gas is ideal, it is going to give us this straight line, because this is 1. Suppose this is unity. Okay, this is 0, 0.5, this is 1.5, this is 2. Okay, 200, 400, 600, 800, like that. Pressure is in bar. Okay, now if I plotted the graph of different gases of PV divided by nRT versus P, I got like this, somewhat deviated from this ideal behavior, and this one like this. I'm getting the graph like this: H2, Hg, N2, O2, CH4, CO2. These were the graphs. Okay, so always remember that H2 and Hg is always going to show positive deviation from ideal behavior. Ideal behavior means Z is greater than 1. What is Z? Z is greater than 1. And if Z is greater than 1 means gases are less compressible. Gases are less compressible. If gases are less compressible, that means there is less force of attraction. Less force of attraction between the gas particles. Between gas particles. If Z, and for N2, O2, CH4, CO2, first at near low pressure, means when the pressure is low, here we can say 200 atmosphere approximately, first it is showing negative deviation. Negative deviation means gases are more compressible. If gases are more compressible means there is more force of attraction between the gas particle. We are forcing the gas molecules to come near to each other. Z is greater than 1, positive deviation. Okay, means gases are less compressible. Less compressible. Okay, did you get that? Okay, tomorrow we are going to discuss the graph of PVM versus P when we are differing the temperature. Means temperature is not going to remain constant. There is also a factor that is temperature. If temperature is going to increase, I have already told you regarding the temperature. If the temperature is high, the gases approaches the ideal behavior. If the pressure is low, gases approaches the ideal behavior. So with that, I have completed this lecture. I hope you can understand this lecture, and we'll meet you tomorrow. Thank you so much for watching.